Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to talk about literal equations. Literal equations is, I think, in chapter 1 or 2 of the Big Ideas book of Algebra 1. So we are talking about literal equations in Algebra 1. They might look a little bit more difficult than the literal equations that you're used to in middle school, but they will start off a little easy. So if you're looking at these and you're an 8th grader taking middle school math, and you're working on literal equations, this is totally fine. If you're looking at it and you're like, holy cow, these are like super duper hard, then you know you've hit the Algebra 1 level, okay? So let's go ahead and let's get started. We are looking for W to be on its own. So I know that volume, this formula is a volume formula. So volume equals length times width times height. I know that since all of these are being multiplied, what I can do is I can actually divide both sides. This is really bold. I don't like it. Sorry. We know that we can actually divide by the length and the height. So like these guys will cancel and these guys will cancel on both sides. So I'm going to end up with my width is going to be the volume divided by my length and height. And that's going to be my final answer. In here, I'm looking for y to be by itself. So I'm going to subtract first this ax from both sides. So essentially, I'm like solving an equation by like removing everything from this y that I want on its own, right? So this will cancel. I'm going to be left with by equals c minus ax. And then because this by is b times y, I'm going to divide this side by b, and I'm going to divide this side by b. And actually, in most cases, you can leave it as this funky looking fraction, and it won't be an issue. So you can do c minus ax over b is going to be what's equal to y, and that'll be fine. Like, that'll be the end of it. Some teachers do prefer if you go in and you kind of like distribute that b out, but I don't think it's fully necessary. So c over b minus ax over b. You could do it, but in my opinion, it's not necessary. If your teacher says it's super necessary, obviously do that, right? Okay, I don't know why I left all this space for this basic problem, but it is what it is. Okay, so they're saying here the perimeter is 2 times the length plus the width, and we're solving for this length right here. So instead of distributing the 2 to everything, I'm going to actually divide by 2 on both sides so that this will cancel out here and I'll be left with that here. So now I'm left with this funky looking fraction, p over 2 equals length plus width. I know that in order to get rid of this w, I'm going to subtract width on both sides. So this will cancel. So I'm going to have, whoopsie daisy, p over 2 minus w equals the length. Okay, so then that's my final answer. There's no way I'm like distributing. Another option that you could do instead of p over 2, it could be like 1/2 p minus w equals the length. That's also an option, but not necessarily like an absolute necessity to do that. Okay, this is where it might get a little bit funny in Algebra 1. And the 8th graders might look at me and say, no thanks. But I think you could fully stick it out, because if you've stuck out the last few problems, this is just like a combination of all of these with one additional step. Okay, so instead of distributing the 2, I'm going to go ahead and I'm going to divide everything by 2 here and here. So these 2's will cancel. So I'm going to be left with s over 2 equals length times width plus length times height plus width times height. I don't need the parentheses anymore because the 2 is not going to need to be distributed. And so because I divided it, the parentheses are gone. Then the next thing that we want to do is we actually want to get these W's, these guys right here, together on the same side. So I'm going to go in and I'm going to subtract this length width from both sides. So I've got s divided by 2 minus length width equals, sorry, minus length height equals length width plus width height. Now, when we're here, ideally, we are looking for my GCF of what those two terms have. So a GCF, if you're not familiar or if you don't remember, a GCF is a greatest common factor. The greatest common factor is something that shows up in both cases, in both terms, okay? So for example, in here, it's going to be my W, because I have a W here and here. And so that's something that's in common. That's a common factor between those two things. Okay. So I'm going to factor out, I'm going to kind of like reverse distribute this W. So I'm going to be left with W outside of what I'm calling my parentheses of like the leftover, the remainders. Okay. So when I divide length by the width, I'm going to be left with the length, and with height by the width, I'm going to be left with height. So let's go ahead and let's rewrite this whole business up top here so that we kind of know what we're looking for. We've got S divided by 2 minus length height equals width times length plus height. And we know that that was reverse distributed because if I distribute this back, I'm going to end up with this with length and with height, right? And I'm going to add the 2. And we know that we can flip-flop these two just fine and it'll still be the same amount. But that's not our goal. We don't want to distribute them back. In fact, what we do want to do, since we're solving for W, is we want to get W on its own. So up until now, we've been dividing by the thing that's outside of the parentheses. Why can't we just divide by the parentheses? Well, in fact, we can. So I'm going to divide both sides by length plus height. Now, this is a little bit of a funky situation. So here's what's happening. Let's get like a different color so we get our final answer. Okay, so final answer is the width is going to equal the, I'm assuming it's the surface area divided by 2 minus the length times the height divided by length plus height. You could leave this in parentheses. I don't think it's an absolute necessity, but it's totally fine. Okay, and then that's my final answer. Now I know it looks gross, but it's totally fine that it looks gross because it's not a problem. Okay, so now we have this one. This is a pretty typical problem because this is the conversion rate between Celsius and Fahrenheit. And so some people like it when they have the Fahrenheit and they're looking for the Celsius, and some people like the Celsius when they're looking for the Fahrenheit. It's honestly, it is what it is. Okay. So here's what we're going to do. Well, we are going to eliminate this fraction first. And the way that we are going to eliminate the fraction is we're going to multiply both sides by 9/5. So on the right-hand side, this 9/5 is going to cancel with this 5/9. And I'm going to be left with 9c/5 equals the Fahrenheit minus 32. Well, Fahrenheit now needs to be alone. So instead of subtracting 32, I'm going to add 32 to both sides. So now I've got the Fahrenheit is equal to 9c/5 plus 32. You could also write 9/5c plus 32. Both are completely acceptable. I don't think it matters. Okay, let's try another one where we have to factor something out, where we have to find the GCF and take that GCF out every single time. Now, I know that when we look at this and this, both of them actually have similar things. So for example, we know that there's a 2 that's similar, we know that there's a pi that's similar, and we know that there's a radius that's similar. However, we don't care about the 2 and the radius, we only care about the pi. So instead, what I am going to do is I'm going to eliminate or factor out, sorry, I need to change that color, to just pi. So I'm going to factor out a pi. So meaning I'm going to take each of these terms and I'm going to divide them by pi. So I'm going to have 2r² left over when I divide this by pi. plus 2RH, or 2 times the radius times the height. And all of that is going to equal the area. Because I have pi on its own right now, all of this information here doesn't have pi. And what I can do easily is I can actually divide both sides by this 2r squared plus 2RH on both sides. And when I do that, this goes away, right? And I'm only left with this pi that's here. And that's ideally what I want. That's my ideal situation. So in here, pi is going to equal the area divided by 2 radius squared plus 2 times the radius times the height. You could leave this in parentheses, but you don't necessarily have to. I hope that this was helpful, and I hope that you stayed, even if you're in middle school, or all the way through the high school section. And as always, I will see you in another video. Bye.